So this is a very quick tour of about a dozen or more PaaS systems and tools out there. And obviously in 30 minutes I won't go into a lot of detail for each, but some screenshots and should give you a flavor of them. So the premise is that we want to build a big application, kind of a complex enterprise application of the sort that we've had to build many times over. So the question is, how can we utilize PaaS and various PaaS tools? For those of you not familiar, if there are any, Cloud Platform as a Service is a technology designed to make it really easier to build, deploy, run, and manage software. And typically it does this by expecting your applications to conform to a certain shape or set of shapes. And because they know the shape, they know some of the ways to deploy it and some of the tricks for managing it. And they vary in terms of what shapes they expect and how they bundle. So it's worth looking at the constraints imposed upon systems by PaaS and how we can bypass those where we need to. So the sample use case, we'll take the ubiquitous chat room, but we'll put some stipulations on it. We want it to be able to scale. And of course, being developers, we're lazy, so we want to spend as little effort as possible. Now, ideally, we'd like to be able to choose the software stack. We'd like to choose where we want to run, the cloud provider or an internal data center. We want our chat room to be successful and fast, so ultimately we're going to want to run in multiple locations, different providers, different countries, and optimize that for cost and for latency over time. And we don't want to be locked in. So none of these are controversial, but there's a sliding scale and there are trade-offs. So we'll rate, just to call out a few of what we'll look at in the first part, sort of big platforms as a service, some of the early hosted offerings, some of the recent open sourced PaaS offerings, and then we'll go in and in the second half go through a whole bunch of tools that actually some of these systems use and which you might use. So the first one, if we're going to take, say, Google App Engine, we might write a WAR file, create the WAR file in Java. That's a standard bundling technique. They all have various mechanisms for deploying it. You can upload it in the browser or use a RESTful API or a command line tool or IDE integration. But it knows what to expect because it's a WAR file and it knows how to run it. Until we start storing your messages and sharing your messages between the instances of the web app, and then things get a little tricky. So the hosted PaaSes all have the solutions they offer. I mean, Amazon gives you a variety of data stores, SimpleDB and S3, messaging. Google is the same, Azure is the same. Now, all of these systems, however, sort of expect you to code to their conventions, their APIs. So we're starting to get into lock-in territory. I'm locked in my app in how it's reading and writing its data. Of course, there's also lock-in with the data itself. I'm also constrained in where I'm running. I'm running in their cloud. I'm constrained about the software stacks that I can use. And they support WAR, so if I'm using a WAR, I'm fine. Or I think most of them now do Java.
So question is only after the presentation, and after the talk. Question is only after the talk, correct?
If you've got something short and relevant,
so
jump out now.
You have the key values over there. Does it mean that it is in JSON format, the data? You have the key values.
You code to their API. You can get it back you can render it as JSON if you need to. But it's actually a bit simpler than that typically.
Oh, okay.
So, that was the three that everyone knows about that have been around for the longest time. CloudBees is another one in this camp that's interesting, focused on hosted build and run. They would do basically the same process, but they were one of the first ones to let me just git push my application as code with a Maven POM. It'll build the WAR, and then it can deploy the WAR. They also provide a MySQL database, which you have to provision it separately, but at least now I'm in familiar territory working with MySQL. I don't have much choice of the software still, and choice of location. But what I do have with them, one of the really nice things, is that they will build it for me automatically. And in fact, a lot of their offering is hosted build, which is non-trivial to set up and manage, so it's a lifesaver. Especially for free and open source projects, they'll give you, I think, free access to builds. They pay for the VM space that builds it. And for several projects, that's been a really nice feature. And they give you a nice dashboard to see what's happening in your cloud. So jump forward and kind of recently we've heard a lot of interesting announcements around OpenShift and around Cloud Foundry. I know some of the Cloud Foundry ecosystem partners are here. And they have both open sourced, as of Monday, everything or nearly everything that you need to stand up these instances yourself in most clouds, subject to some of the limitations or extensions to Bosh to use JClouds. And this open source removes a lot of the lock-in. I can now run it in my choice of cloud, subject to my being able to set it up there, which is a fair amount of work. A lot of companies are making that easier. It's also helps the ecosystem be able to develop new software stacks. So if my favorite programming language isn't in there, I could add it. It's a lot of work to add it, but it's possible. So it's not quite bring your own binary yet in these systems, but they're getting there. So the first one, Cloud Foundry, is about a year old, and Staccato and AppFog have been commercializing these for a while and extending them. They're available, of course, at cloudfoundry.com. They have a number of runtimes you can use, shown along the top. They also have a rich library of services. Many of the tools that you'll want to use are available. Many of the tools might not be available yet, but hopefully they're coming. There's some issues with your control over those other tools and the VM instances you wanted. So if you needed to set up, say, an SSH tunnel into your apps, that could be a little tricky. As we'll bang our heads against later on in the workshop. But of course, they've got the nice cloud provider interface shown on the right. If you've heard of Bosh CPI and wondered what CPI stands for, it is that cloud provider interface. What Bosh stands for remains a mystery, I think. And it's got a similar command line tool to the bees, where you run a command to push the app, use the same tool to configure it. This is a fairly transparent Ruby application that's doing some REST calls under the covers. The REST API is not published as yet, but it's easy to reverse engineer if you want to go down that road. Yeah.
You said Ruby can be used in Cloud Foundry. Can Ruby be used in those basically clouds by Amazon or Azure and Microsoft's cloud?
I'm not sure what the state of Ruby in those systems is yet. Does anyone else?
You can run it, but they don't provide it as far as I know. And certainly Amazon doesn't provide it, but we run a ton of Ruby apps there. So
I mean, I haven't called out Engine Yard and Heroku, who do a lot of work, especially in the Ruby PaaS space. So OpenShift is the Red Hat platform as a service that was announced about the same time. It builds heavily on Makara, which was around for several years before then. And again, it supports multiple stacks, multiple services, multiple clouds. For anyone from OpenShift, I apologize. I know you've had a rebrand. I've not done a rescreen grab, so forgive some of the out-of-date branding. But this gives an experience that in the web app, you can configure quite a sophisticated set of stacks. You're still limited to the choices that are on offer, as in Cloud Foundry. OpenShift also provides some simple but very useful auto-scaling, where we can choose a metric to use for scaling and set the parameters, and it will do that for us automatically. Now the parameters are limited to basically requests per second or CPU usage. Usually you have a more sophisticated function in a real application that you'll need to use. But as a starter, that's one of the most sophisticated things out there in a kind of a prepackaged PaaS system. And when your app's running, again, you get the monitoring information. OpenShift lets you drill down and actually see the instances running in your choice of cloud. And so you can SSH to the machines and do what you will with them. So this shows SSH access onto the box where we're checking out which packages we're using. VPN is probably no longer called that, but that refers to the Vostok Package Manager, which is the original system, and it kind of does betray its roots. It's built around packages that are managed and get installed, but the packages have hooks, so you can do things to them and get things back from them. And your applications do tend to be composed of components that you'll want to be able to have those hooks into. So a quick roundup of these systems. Again, some of these are out of date, so we should, the more recent ones are relatively safe from lock-in. They all sort of make it difficult if I needed to bring an unusual piece of software to the table. I need the snapshot version of Cupid for some reason. That's not going to be available in any of these. You could write it, but that's a kind of a fairly significant job. But if you're using standard components that are supported in these and you're happy with the versions they choose, they're excellent, even if that's just for part of the application. They don't, as yet, any of them allow you to, out of the box, span multiple locations. So each of these is really managing a cluster. So if your application, in our case the chat room, is global, we could put a cluster into any of these systems, but we still have other clusters running elsewhere.
What's the difference between X and the check mark?
X is it's not supported, the check mark is it is. So we could write a pretty powerful, nice chat room in any of these, and many of them will even give us auto-scaling. They make it very easy, which is a huge plus. But if I have some custom requirements around my software stack or data tools, if I needed to use Hazelcast, for instance, I'd have a tough job. Again, when I start going into custom environments, again, life gets more difficult. And if my application is going to be global, these aren't yet the answer. So as far as you can use these, they'll make your life much easier. But if you want to do more, you've got a do-it-yourself job. And that's where a lot of the tools come into it. So recall we're building a chat room, and say our ideal stack is Tomcat. We're doing some processing in Monterey, which is our processing fabric, or you're doing Hadoop processing. And you've got a data caching fabric. And you want to run in US, Europe, and Asia. You need to scale within each tier. And then we've got chat rooms that actually these chat rooms should probably follow the sun if they've got worldwide activity, so that they're hosted closer to the people using it most of the time. So let's say that elaborate the use case, make it a little more difficult, a little more representative of big applications. How would you build this? There's not an out-of-the-box solution, really. There are a lot of software tools that will help you, though. And so in the second half, we'll very quickly, really one slide on each of these, maybe two, cover some of these tools. And we'll conclude by introducing Brooklyn, which tries to address this problem of stitching together multiple locations, multiple regions, and putting some management policies in place around that. So Apache Whir is probably the closest to the PaaS systems. This grew out of work deploying Hadoop. Hadoop configurations are notoriously cumbersome to set up the site.xml files on the various machines, manage those roles. So Hadoop automates a lot of those. You come and can write a recipe like shown at the top. I want one name node in job tracker and 5 data nodes and task tracker instances. Push AWS EC2 as the provider, give it some credentials. We run that, and it will build our cluster for us with Hadoop set up. And it actually goes so far as to give you the XML you need and to give you the proxy that you need in order to connect to it if it's in a different subnet. Chef is something most people are probably familiar with. A little lower level, it's about provisioning the machines once they're set up. So you have recipes, defined roles for what should go onto a machine. And these roles are able to give you some metrics about what's happening and some commands for poking and prodding it. An example recipe, it's got a command line tool that lets you run the recipes and monitor what has been done on various machines, what roles are there. So similar to Bosh, which was spoken about last night, much earlier than Bosh. Kind of Chef and also Puppet, which is coming up next, predate Cloud. And I think there have been some work to make it more cloud friendly, but it is a slightly awkward fit. When you have cloud, you want to do some things totally differently. I might be getting an AMI that has the stuff pre-installed, so I don't need you to install it. So I think Bosh sort of has some advantages in the cloud world. The scope of Puppet and of Chef, the number of recipes out there, what's supported is voluminous. So kind of the ideal is to be able to combine all of these and use whichever of these is appropriate. Puppet, I should say, has mCollective, which is an interesting management system for Puppet that kind of gives you a message bus and some monitoring for the roles that you've deployed. Juju's a fairly recent entrance. It's a Ubuntu system. Of course, their name of choice is Charms. These are like packages, but they're cloudy packages and manageable packages, and they have a simple but fairly elegant inter-component configuration model. So I can say that this one has a relationship to a MySQL instance or a database instance, and it will find the right charms. And it exposes operations. It doesn't have a notifications or metrics mechanism apart from the operations, but you have getters in there, as far as I know.
So this is Ubuntu specific?
It is Ubuntu specific. Yeah, that's the run. The others are mostly Linux specific. There's some work getting the others to run in other OSs. Palette's an interesting one, built-in closure. Similar idea for managing nodes. Their choices, you're building them up from crates. So just to come back to OpenShift and also Cloud Foundry a little bit, you can use, because they're open source now, you can use parts of what they have. So you can dig down into the underlying package manager and packages that OpenShift uses, call them cartridges now, and get the monitoring info and the operations. I think that's Ruby. I believe that this is Red Hat specific. It would make sense. Someone can correct me if not. But again, it's probably a somewhat similar idea to Juju. Probably because it's somewhat older, I would guess more mature. But Cloud Foundry, similar. You can get the underlying VCAP code and play around with the components. There's a lot more intertwining, so it's probably a little harder with Cloud Foundry to pick and choose just a few things and use them out with their intended context. But it could be done, or hints for how to do it would certainly be available. So if something's supported in one of these systems, you might be able to copy 80% of the code when you write your own deployment. Bosh was mentioned yesterday. Some nice monitoring support, messaging support for the things you've deployed in Bosh. I'd call out that. It is wonderful that all of these are open source, so you can just get them and use them or use parts of them, or at least see how they solve the problem that you have. I should also add that most of the communities have been very responsive, particularly on Twitter. If you come across some questions, a lot of people want to discuss it and will help you. Has been my experience. Cloudify from Gigaspaces is one of the most sophisticated offerings that, yeah.
So what messaging does it use to communicate between the entities?
In Bosh?
Yeah.
That's a good question. I know they have RabbitMQ, but I think they don't use Rabbit. I'm not sure what is used.
The reason I'm asking is when it's under detection, the messaging stops, your whole cluster gets closed up.
Interesting. It should be, hopefully it would be pluggable, and so you could drop in a different messaging system, but I don't know for sure. So Cloudify is a very interesting one that kind of brings a lot of the concepts we've used together and lets you as the application developer specify what components go into your application as a very simple, nice looking, groovy DSL. And then you can push a button and it will run it. It will roll out these components and you can monitor them. It also has support for putting some policies around it to scale out and scale back within a cluster attached to the components you use. They have a neat solution to the problem of running a remote script. They use Ant for some of that, I know. Nazi is not shaking his head, so I'll assume that's accurate. And so I think this is the first one of the first systems to make management a first-class concept, along with how's your application deployed. You are using the entities that they represent. You can extend the entities they have, but there's some work to add new entities to the vocabulary. Now, many of the tools we've used, including Cloudify, if they say that they target lots of clouds, more often than not, they'll be using JClouds, which is a simple Java API for compute and storage, networking, and a few other things, that you just drop in a string to determine whether you want to run on Amazon or CloudStack or OpenStack or vCloud, and what endpoint. So it means that your application code and your management code is now isolated from the actual API of the cloud that you're using. You're no more asking everyone to code to your cloud's API. I guess many of you will see the no API sticker, which we jokingly made, and have gotten a lot of kind of curious, almost angry looks from people until we explain that we're not against standard APIs, but we're very much against custom APIs for their own sake. If there is a perfectly good cloud API out there, use it. Now, if it comes from a company who hasn't given you legal rights to do so, we can understand making your own. But nowadays, there's really no excuse for a new cloud API, I would suggest. Certainly extensions are open, and there's discussion there and innovation there. But, so JClouds tries to give you that simple abstraction layer, and I think at least 4 or 5 of the tools we've mentioned use it. Bosh does not, and that's sort of why it's got a smaller set of target environments. So to come back and review our ideal application that we wanted running in 3 locations and scaling within each tier, we found a lot of tools that would help us roll out the constituent components, so we can get our Hazelcast set up in Amazon. We can get Hadoop running in a cloud stack. Cloudify give us some ability to put scalability logic if we're running in Cloudify or if we're targeting OpenShift. I'm still left as the developer scratching my head thinking, okay, suddenly my world's gotten a lot more complicated because I have to follow this technique here and this technique here and this technique here, and actually it's all one application, and I still haven't solved the basic problem of I want to optimize my global footprint. What's the point of using cloud if I'm not using it intelligently, if I'm not changing where I'm running from time to time? And so I'm still left writing my own management logic for moving these things around. This is the problem that Brooklyn seeks to address. It comes at it from the point of view targeting the application developer, giving him a way to say, my application contains this, and when I start this, if I'm starting in Amazon, use fixed AMI. If I'm starting it somewhere else, then use Puppet. If I'm starting it in Cloud Foundry, I'm going to VMC push it. So because it's shaped around the application as code, it lets you easily take tried and tested software off the shelf or PaaSes that you want to use, and those can be parts of your application. Brooklyn gives you a way to specify the combination of those. So what entities do we want to use in our application? What customization am I dropping in? What WAR file am I uploading, schemas? What policies do I want to run? So if I'm targeted at OpenShift, I'll happily let them manage my cluster size. If I'm looking at Cloud Foundry, they don't manage the cluster size, so I need to run a policy that's listening to the CPU. Going up the way, when I'm thinking about, well, where is demand coming from? Well, everyone in the OpenCloudConf chat room is coming from California, so let's make sure that's hosted in our California data center just now. Brooklyn lets you attach that policy to what's called the fabric level, moving things between clusters. And again, it's built on JCloud, so you can target most clouds as well as legacy infrastructure. We do a lot of bring your own node type deployments. There's also a special local host mode, because one of the things we do frequently running it is test it on our local machine. And we want that to be as fast as possible. It does this as code, so it's testable, it's reusable, trackable, split it up into modules, share it. And we open sourced it 1 month ago so that we can have more community people vetting the entities, contributing entities. And where we want to get to is figuring out the best policy sets. So there's a decent spattering of starter policies in there. But when you start thinking about how am I going to manage my multi-cloud, multi-tier application, we'd love to have that conversation on the Brooklyn mailing list. That concludes this talk. We'll take some questions, but remind you, in this afternoon session, we'll be going through JCloud's Whir and Brooklyn, built around a Hadoop example, showing how we can set up the complex Hadoop using these tools, and then also how we can set up a web app to use Hadoop and deploy our web app to some of these using some of these systems. Also talk about using it doing Cloud Foundry and OpenShift. So, yeah.
Is there any difference between the open source Brooklyn and would there be a sort of a cloud shop enterprise version?
My pockets are empty. Brooklyn is entirely open sourced, as is JCloud's. There are no closed source, behind closed doors things. Other questions? Yeah.
So you expect you test it on like a local configuration, like your laptop or something, and then the users are supposed to test it on bigger clusters and their production, whatever environment. If they see problems, you report it. Right? But how are you going to reproduce it? I mean, is he going to hold on to the cluster for you, or?
This comes up frequently. One of the nice things about it being code is that they can kind of point us to the GitHub repository where it's hosted. If it's open source, we'll zip it up and send it to us.
You tested it on your laptop, you didn't see the problems.
If they're running in a cloud, I can set up my cloud credentials. We can both run it in Amazon. It'll pick up the same AMIs running in the same Amazon. And more often than not, it shows the same problem. Because you have a precise way to reproduce exactly what happened.
So he is supposed to keep his runtime alive to debug the problem. That's my question.
They can do that also. But no, if they just ship us the code and we run the code, it works. It's not like it's being deployed to a service. I don't need access to their service. I can push it out to Amazon and recreate the exact same thing they created and hopefully hit the same problem and help them out. Okay. Thank you all very much.